Noon or good evening. Let me start again. Good morning, good afternoon, or good evening, depending on where you are in the world. Welcome to today's DevOps.com webinar, SRE, How Observability Tools Help to Implement Reliability Engineering, presented by Instana. I am joined today by Roman Zeibel and Yury Oleynik, and we have a great presentation on tap for you today. Before we get started, though, I need to go over a couple housekeeping items with you. First of all, today's event will be recorded, so if you miss any part of the webinar, you'll be able to go back and watch it again at your leisure. We will be sending out a link to access the webinar on demand following the presentation, so keep an eye on your inbox so you don't miss it. We are taking questions from the audience, so you can use the Q&A interface on your console there, sorry about that, to submit your questions into the Q&A section. We'll have a polling question for you today, so keep an eye out for that so we can get your responses in. And at the end of the webinar today, we're doing a drawing for 4 $25 Amazon gift cards. So stick around to see if you are a winner. So with that, I'm going to get right into it. I would like to introduce Roman Zeibel. He is a customer engineer at Google, and Yury Oleynik, who is a product manager at Instana. Welcome. Thank you so much for joining us.
Thank you very much, Sharon. And yeah, welcome everybody to our talk on how reliability can be implemented with tools like Instana. So let's dive into the topic. So today we would like to talk to you about what actually SRE is and why it exists. But then also we would like to go over a demo after we've covered the sort of this theory. And during the demo, we will actually define the basic components of SRE, like service level indicators and objectives. And we will see how error budgets look like, and we will also talk on how to react and in case of an incident, and how to manage it before we conclude. So why SRE? There's this obvious case, right? You might have had recent issues with service reliability. This is sometimes why people come to Google, people that probably run workloads on Google Cloud, come to us and would like to know more about it and how it can help them improving their reliability stance. But also there's scaling. And this was actually the trigger for Google many years ago, why we started developing this concept of site reliability engineering. And this is called site because it used to be just google.com website. Today you could apply it to systems and services that you are running. So it can help with scale, but it can also help with if you have frictions, and the classic friction between developers and operators. When developers write code, throw it over the wall, and tell operators, please run it, make it reliable. But also if you have organizational silos, right? When you have, for example, you have product and development and IT that runs those things. If they are kind of detached from each other, and SRE is something that can help with that. And it can help with that through a mechanism. So now let's talk about what is SRE. Basically, it is an engineering-driven way to do operations. Right? So it's what happens if you ask an engineer, a software engineer to implement an operations function, kind of. This is what came out at Google, at least. And it has 3 core principles. So the first one is reliability is the most important feature, right? If your app doesn't work, you kind of there's no point to it. The second of all, reliability is defined by the user. It's not defined by your classic metrics. For instance, the classic metric would be, right, my server is up, the CPU load is not too high, my memory is not used up. Everything looks fine, but it doesn't mean that the user has a good experience. It doesn't mean that there is reliability. And then what we also say in site reliability engineering is that if you want 3 nines, you need good software, right? You need a good team with good practices to develop an application. You need to test it well. But if you want to achieve 4 nines, you also need excellent operations. So you need a lot of good automation. You need ways to detect errors early, to roll them back quickly. But if you want 5 nines, then you also need an excellent business operation. And this means putting effort into achieving 5 nines, and also considering this trade-off that you won't be able to be as fast if you want to achieve 5 nines, right? You cannot have a high deployment frequency, for instance. Okay, and now then there's this white elephant in the room, but there's DevOps, and I often hear DevOps and SRE, and sometimes those both things at the same time. Does it mean that SRE is something different? Is one thing better than the other? And I think it is something that is very similar. But let me try to explain to you the differentiator. DevOps, I mean, the DevOps manifest, it has 5 things, right? It tells you to reduce organizational silos. It says you should implement change gradually. You should leverage automation and measure everything. Well, it doesn't tell you exactly how to do it. So it tells you the what's, but not the hows. And so if we look at SRE, it's a lot more concrete. SRE is a prescriptive way to do those 5 things, right? So if you want to reduce organizational silos in SRE team, they share ownership of the systems and the products that they develop and run. And if you want to accept failure as normal, this means in SRE's cases that you define service level objectives where you define that, for instance, you want 3 nines of reliability, and that it is okay to have 0.1% of unreliability. And as well as this cultural aspect of blamelessness is a core value of SRE. So this is a more prescriptive and less abstract concept of DevOps. So those 2 things do not conflict at all. So before we go on, there is a polling question that we would like to ask the audience.
There sure is. Thank you so much, Roman, for teeing that up for us. All right, so you're going to see the polling question come up on your screen. If you wouldn't mind taking a couple seconds and clicking an answer for us. Do you practice site reliability engineering? Yes, no, or not yet? So we're going to give you just a few seconds to weigh in on that, and then we'll circle back with Roman and Yury and see what the results are.
Yeah, thank you, Shannon. We would just like to get a feel of if you are already using it, because what we often see is that SREs can be different for different companies compared to, for instance, the books that define it. And so this would give us a kind of an overview.
Yeah. It's definitely a hot topic, and one that's gaining in importance, I think. All right, so let's take a look at the results here then. It looks like, do you practice site reliability engineering? 29% of the audience says yes, 27% says no. And the majority of folks, 44%, say not yet. So I think that bodes really well for SRE. How about you?
Yeah, thank you very much. It's very interesting, let's say, data set, I would say. And I think we have the right audience here to talk about what SRE actually means and how it works, and especially how we can do it with a tool like Instana. So let's go on. Before we can talk about the things that Yury will show you in the demo in a couple of minutes, let's talk about terminology, because it's otherwise it's easy to get confused. So the first thing is what we call the critical user journey, or the critical user interaction. It is something that describes how, when a user interacts with a system, it could also be a system interacting with another system, but let's focus on the user here, to achieve a certain goal. So a user wants to browse a shop, for instance, and they try to achieve a certain goal, right? Browse something. It could be an explicit goal, but browse something now and responsibly. It could be an implicit goal. Then the second terminology that we use is the service level indicator, or the SLI. And this is something where you use metrics to measure how well your user interacts with a system, right? So what this looks like in the definition we will see very soon. Then there is the service level objective, and this is basically taking this SLI, this indicator, but also giving it a goal and saying, for instance, I want my users to have a 3.9 availability or latency below a certain threshold over a certain window. So you add to the SLI, you add a window. This could be a month, 2 weeks, a year, whatever makes sense for you, and a goal like 3 nines, for instance. And then if you take the 100%, right, and we mentioned earlier that if you want to achieve 5 nines, you need excellent business, you need to make trade-offs. And I didn't mention it then, but I would like to make the point now, is that 100% reliability is basically wrong for most things, because then this means that you are very stable, but you cannot move, you cannot take any risks, you cannot deploy new features, right? So if you take 100% and subtract whatever you have set as your goal for the SLO, this is basically your error budget. This is the time window, let's say during a month, where it is okay, where you say, your developers, your operators, and also your product managers say it is okay to be unreliable during the time, to use it, for instance, to deploy new features or have maintenance. So this is how we define reliability, right? Reliability is when users are happy. And they are happy if our system meets their expectations. And their expectations, as I mentioned earlier, can be explicit or implicit. And so basically, we set a certain threshold. For instance, let's look at latency, right? You can do, for instance, research and then find out what is the threshold where my users perceive my application as a responsive and well-working application and are happy. So let's say it's 200 milliseconds of latency, and then basically, if your SLI is worse, then your users are unhappy. If it's above that, then your users are happy. And the same goes for other types of SLIs, which we will talk about soon. So now let's talk about how you can model a critical user journey with Instana. And I will stop sharing now, and Yury will take over. So give us 5 seconds.
Yeah, thank you, Roman, and hi everyone also from my side. I am now switching to my screen so that I can show you how you can model a user journey in Instana. And as Roman mentioned, right, a critical user journey is a particular slice, particular piece of functionality, right, that is really, really important for the whole application, right? And this is kind of the scope, the foundation for defining SLIs and SLO. And here I have an example robot shop application. This is like an online shop, right? That we monitor with Instana. So here we see like there are like in the last hour like 50,000 calls and so on, right? And we can actually have a look what it actually consists of, right? And here we can see that there is actually a bunch of services communicating with each other, right? There are some backend services, MongoDB and Redis and so on, and there are some front-end services, right? So SIEM and SIEM QA here, right? And if we look at our front-end service, this is basically what our users are interacting with. We will see that it consists of a bunch of resources, right? And today we are going to be modeling a critical user journey for a cart in our robot shop. Essential resources for that or endpoints are the get cart, get/API/cart view, cart total, and there should be also a get products, right? So these are the 4 endpoints that are important for us, and this is the critical user journey. So we've discussed with a product manager, product owner, maybe like what are the important resources now. Let's actually model that with Instana, and you can do that by creating a new application perspective in Instana, and you can do lots of different stuff with that. But one of the things is a critical user journey, and this is actually quite simple yet very flexible and powerful, because what it allows us now is to really pick up very precisely, right, what we just said, the resources that are critical for our user journey, which is API cart view. Then we say, or the other one was cart, get cart. Then one more filter, or endpoint. What did I say was the last one? The cart total. Let's filter to cart. Yeah, okay, there it is. And we said there is one more about the product. And the product. All right. So now we actually see that, okay, looks like we've got a bunch of services here. What we're actually interested in, that we actually only want this service, right? The SIEM Kubernetes demo service. So how we go about that? Quite easy. We just put brackets around and say that we are only interested in the service name equals to this guy here. Okay. And we're as Roman mentioned, we're only interested in the in the user experience, so we don't really care about what happens downstream for defining service level indicators. And we focus on the inbound calls. We give it a name, critical user journey cart, and we are done, right? So this is how we get the model critical user journeys in Instana. And when this is done, and I actually already have created one for us for this webinar, this looks like that. Then you have your, the golden KPIs, the number of calls. You can see the error rate, the latency, as well as some other things. And now it can be used to define service level indicators. And for that, to learn how we do that, I'm giving back to you, Roman, to tell us what an SLI is and how to define. Okay.
Yeah, thank you very much, Yury. We just seen that with an APM tool like Instana, in this case, with application perspective, you can tailor what you want to consider for an SLI with the help of application perspectives. And this is a pretty powerful tool, I think, that makes it easy to define what an SLI, what a user journey should look at, so to define whether the user is happy or not, right? So now let's say we have defined define what we want to look at, and it could be latency or availability, for example. So the SLI, as I mentioned earlier, is something that models this user journey. And basically what we want to achieve at the end, to have a metric that tells us if the user experience is good or not, right? And so the way we do it is we compute this fraction of, we take all the good events. For example, if you have a web application and your user interacts with the server, and you send HTTP requests and you get HTTP responses, right? And those HTTP responses, they usually come with codes that can be interpreted as, for example, code 200 means success. So this is something that is a good event, and then we can say, okay, let's take everything that is kind of models a successful interaction with the server. So all the 200 events, maybe 300 events, because they are redirects. Some of the 400 events may also be okay, but definitely not the 500 events, because those are server errors. This is something that where it's our fault, and the user definitely has a bad user experience if he gets a 503 back from where the server is, for instance, overloaded, or something is not available on the server. And right, so this is basically how we would do it for a web application, but there are different types of SLIs, right? You can look at availability, so if something is up or not over time. You can also look at, for example, data processing. You could look at how fresh is my data. Is it 4 hours old or 5 minutes old, or is it 2 weeks old, right? So if you have an application where you want to have dashboards, you would like to see graphs, their data freshness is definitely important. Also correctness. If the data that is received at the client and then rendered, if this is correct or not. You could also look at throughput and latency and so on. But let's focus at availability and latency for the time being. And there are also two categories. One is you can measure requests and put them into the good events and the valid events. And with valid events, we mean all events, basically. That all events that model this user journey. And this can also be Windows-based. So you can measure a certain value that is better, for example, than 100 milliseconds during 5-minute periods, and then compute the same fraction over it. But we will see this very soon in Instana, because it will ask you, do you want a request-based or Windows-based SLI? So now let's let Yury show you how to define the SLI in Instana.
Yeah, thank you, Roman. So this we don't need anymore. And yeah, so how to now define an SLI for our critical user journey card. So I already have some defined for us, but we will go through it again and define in one, right? So for that, we go to the custom dashboard, where you can create a service level objective widget. And here you can also manage your service level indicator. So as Roman mentioned, right, there are generally two types of SLIs that you can have, right? I mean, there are like availability, performance, right? This is what we one dimension, but then how you implement it, there are two types, right? One is this window-based, so we call it time-based. Another one is request-based or event-based, which is the same. So for the event-based SLIs, essentially what is important is that, as Roman said, there are good events and there are all valid events, right? And with Instana, we go a little bit further, so we allow you explicitly define the good and the bad events, right? And the good and the bad events together, they make up a valid event. Why is this important? Because this way you can, we are very flexible in terms of defining each category. So you can, for example, also exclude or ignore certain events, right, from your user journey, which are which are not relevant. So in certain cases, for example, the status code 400 could be something that is okay, right, or okay essentially for you. It doesn't mean that system is not available, and you might have some additional traffic, which if it would have been included would bias basically your service level indicator. So you actually want to focus it on only the 200s and 500s as bad events, right? And 200s being good events. And that's exactly what we allow here. We provide a very, very flexible way of really defining precisely what the good events are. So in this case, for example, under 299, including status codes, and everything bad has to be about 500. As you can see, we are excluding basically here everything in between. And yeah, when this is done, right, you give it a name, just to kind of show you how it looks like for time-based. It's essentially more or less the same. You can also additionally specify service or endpoint, but which you typically do not need to do, just in some certain edge cases. But here you can then choose one of the metrics that we offer. So for example, latency, call count, error rate, and so on. Choose an aggregation if applicable. So for example, 90th percentile for latency, and set a threshold of, let's say, 100 milliseconds or 1000 milliseconds, right? Which will then be evaluated in the way that, every minute we would then qualify whether this minute was a good or a bad minute, right? So basically whether the 90th percentile was above or below that threshold. And then the same formula applies as Roman just showed us, right? The good minutes will be at the top, and then in the denominator we will have basically all the minutes in our compliance period. Yeah, that's how the SLI is defined. And Roman, back to you. Tell us how you define a service level objective.
Yeah, thank you, Yury. Cool. So we have the SLI, right? We defined which requests we would like to look at, which go into the to the top of our equation, which ones go into the bottom of our equation. And so the next step would be to add a goal to this. And it's important to say that in SRE, people that should participate in setting SLOs, it should be generally three parties, right? It should be developers, it should be operators, but it should also be someone from the business side, someone who is responsible for the product. Like at Google, we call them product managers. At Instana, it's also a product manager. Usually in agile development, you have this product owner, right? And so then you need to understand, you need to sit down and understand, in order to keep your users happy, how many nines do you want to achieve, right? And it depends on your business requirements, and it also depends on the historical data. And if you can actually, if your current reliability track record can support it. So then maybe start with 2.5 or 3 nines, which, for instance, already 3 nines already mean something like 40 minutes a month of unreliability is okay. And you add a compliance period to it. So this is the window of time that you want to look at before it gets kind of reset. And there are two types. One is calendar-based. For example, your compliance period starts at the first of the month, right? And then it ends at the end of the month, which you can do. But there's also the concept of the rolling window, where you simply look at the last 14 days or the last 30 days and see how your SLO, if your SLO is met, and how your SLI develops over time. So in this case, basically we set the goal of 3 nines of for our SLO, and we set the compliance period to 28 days. So basically, you want to achieve 20. You invest 28 days most of the time to be a good experience for the customer. And so next, we would like to look at how you define the SLO in Instana. with Yury.
Thank you, Roman. All right, so let's define the SLO then in Instana. And yeah, so as you know, we have defined our service level indicator, availability, we have our user journey. Now let's set the SLO target. So and here, as Roman mentioned, right, so there are different compliance time, they're called time windows. So right now I'm looking at a fixed time interval, but we also support rolling time window or dynamic time window, basically, so that which you can then set ad hoc with our time picker. So for example, if you want to provide a report maybe on a specific time frame. Okay, as I said, we're looking at a fixed time interval, and here I have the duration of only 1 week. That's basically what you can use in Instana to get a preview, right? For and this is what we will be looking at right now, which starts on Monday this week. And currently I have 2 nines here. So let's see, as Roman said, 2 9.5 is something you can start with. And what is really coming back to that discussion of like how many nines, right? It's really difficult to understand what would be appropriate, what is sustainable, right? So some parties would be pushing for higher numbers, others would be a little bit reluctant. And with Instana you can immediately kind of get a preview how the value that you're looking for, that objective, is this sustainable at all, given the past performance. And this is what you can see here, right? So essentially our SLI on this since March 15th, so since Monday, was only 99.47. So we're actually 0.03 percent points below our objective, right? So as of now, we can already see this is not achievable, right? Here we can also see the error budget, right? So you can have tables for seeing like how many minutes you can have, right, per month, because the number of minutes in months there, this is fixed, right? So we can derive that. But what if you are using request-based service level indicators, right? That will vary the error budget, with the calls you get, right? So as you can also see here, the error budget is increasing over time, right? Available. So we have at this point 170 calls available in our error budget, and it's growing, right? And then, as you can see, around 10 a.m. today, we are started to really consume a lot of burn a lot of that error budget, so that actually like almost like an hour ago, we have spent all our error budget available. Okay, so we have spent 395 calls or requests, right? Have been not available according to our definition of service level indicator, and we just had 379. So here you can very interactively then play with this and probably say that, okay, looks like the best we can do at the moment is 2 nines, right? And you get this live basically reflected and understood. So with that, Roman, back to you. Let's talk about error budget policy.
Yeah, thank you, Yury. I find it amazing if you use a tool that has this tracing data available, how quickly you can see how well actually you are doing, and what levels, what objective levels you can achieve with this, to have a meaningful discussion with your 3 parties, with the PMs, the operators, and the developers. And so the error budget, right? I mentioned earlier that if you subtract from 100% whatever your SLO is, this is the residual. This is what you get to play with, more or less. So it's the accepted unreliability. It's time for experiments. It's time to do deployments, which can be risky, which then you can roll back and hopefully not burn your complete error budget, which is something that can be expressed in, for example, if your compliance window is a month, and you can say I have 21 minutes per month of unreliability, which is okay. And what happens if you run out of error budgets, right? So let's say you had 21 minutes, but you already had 30 minutes of unreliability during the first 2 weeks of the month. Well, then, for example, there is the basic approach, which is like a binary approach. You just stop doing anything that could lead to downtime or bad user experience, and wait until your error budget replenishes. Right? It replenishes either at the beginning of the month, if you have a fixed, calendar month-based error budget compliance period, or if you have a rolling window, you just wait a couple of days and you get a bit more of your error budget back. And this it incentivizes to have behaviors to focus on the customer, right? If you had a lot of downtime, you should not continue as you did before. But you can also do it in a bit more advanced ways. For example, you could say that let's align our compliance period to the sprints that we are doing in our agile team. Like 2 weeks is a typical sprint length. Some people do 1 week, but let's say 2 weeks. You can also do things like a staggered approach of reacting to your error budget consumption. Right? For example, you could say, right, so most of the time my developers spend maybe 5% of their time working on reliability features, so making my system more stable. But most of their time they are spending on new features and solving killing bugs. But if I burn my budget at a high rate and I don't know the root cause, for example, after a couple of days, then you could say, all right, let's switch the developers to working on reliability instead of 5%, let's say 30%, and therefore improve my general stance for the future and potentially reduce my error budget burn rate by a significant amount. Another policy is or instrument could be silver bullets, right? For example, silver bullets are overrides that could be done by the business side to, let's say, you don't have enough error budget to roll out a risky new feature, but it is crucial for your company because you are maybe competing, and then PMs can say, all right, let's still deploy this feature even though we don't have the error budget for it, but this is important for us to survive if we're a startup, for instance, for example. But those things should be written down in your error budget policy, and those things should be limited, right? Like, I don't know, 1 silver bullet per quarter or 2 per year, something like that is a common practice. Yury, if you go to the next slide, I think we can now talk about what happens if you get a major incident, and so first of all, how you should do the alerting, and then how you can be prepared and reacting during that time. So right. So alerting, right? Generally in SRE, a human should not be paged because something happens that does not really that doesn't really kill the user experience, right? If this happens, maybe some automated ticket should be generated, and someone should look at it later. But if you burn a lot of error budget within minutes or hours of the day, and you can, it is easily to see that you will not have any error budget left at the end of your compliance period, then you should definitely get an alerting, and humans should be involved because someone needs to take action. And so the second part is in order to handle an incident well, you need to be prepared, right? So basically, you need to practice this. For example, if you can practice disaster recovery, you can do disaster recovery training, is something that we do here at Google. You can create playbooks from outages that you have simulated, so that this mean time to recovery is as small as possible to to stop burning your error budget when an incident happened. And then the third part is organization and communication is extremely important. So you have like 3 personas during an incident that you should define. So someone that calls out that this is a major incident. This is the incident commander, and then someone who from the operations teams and operations lead that looks into the issue and looks into the mitigation, and then very importantly, someone to communicate this, a communication lead, someone that tells the customers, even if it's some underlying systems, but then there are other operations people that will be upset that there is an issue and you're working on it, and also, and very importantly, after the issue has been resolved, you should also communicate that the incident is over now, and later provide a root cause analysis for what happened and what you will do for this to not happen again. And the last important thing is that what we practice here, for instance, at Google, is that when such an accident happens and we are doing a postmortem on it, that we do it blamelessly, right? Because it's never a person's fault that those things go wrong. It's usually systems and processes that can be improved so that those things cannot go wrong, or mistakes cannot be made, maybe through automation. I've seen some questions on it, which we can talk later about in the Q&A. So the next is the error budgets and alerts and root cause analysis in Instana that Yury will show us.
Yep, thank you, Roman. And yeah, if you have you can extend your incident team with our Stan robot. So this is our site reliability robot. Yeah, so with Instana, you can do many things to help understand, right, what is causing the issue, and to get the foot contact and get ultimately to the root cause, as well as to be, of course, alerted about the problems, the incident in time. So one question to ask is like, if we have our incident error budget burned, right? So looks like we started to have an incident actually over here, right? What is causing that, right? So who are our error budget offenders, right? So, and this is you can very easily do. So you just select that area on the chart with the error budget burned, and we take you immediately into our unbound analytics section, where we filtered down all the traces to exactly those which have caused the problem. And we just look in any of those traces, and okay, looks like we immediately see what happens, right? So they connect to the database, takes very long, right? And here we can see that, okay, looks like something was connecting to our database is happening, which is causing the whole request to go erroneous, right? So this way you can then immediately understand what is the problem. Then, okay, that's we understood. So how do we prevent this from happening next time, right? So what about alerting? Also quite easy, right? So this is our critical user journey card, right, with major KPIs or golden KPIs, right? Latency, erroneous calls, and you can add an alert to that, and Instana will essentially automatically generate alert for you, right? So all you need to do basically is to choose one of our alerting blueprints, which basically define what kind of problem do you care about. So in this case, slow calls, right? And we immediately compute the metric, derive a baseline, right, based on the past performance. So if you remember, the way we defined our service level objectives basically based on our past performance, right? Which means, if we would, keep the status quo, right, we would be on a safe side. So this is what we do here, and immediately you can see it looks like we would have got a number of alerts because of that incident going on since 10 a.m. in the morning, right? And in the next step, you can further narrow down the scope, right, of this critical user journey. So for example, here we see the services involved, right, or we can add or filter the scope very flexibly. Essentially, even with this tool, you can even narrow down your alert even to a specific user or specific user group. And we would on the fly derive basically the whole alerting configuration, including the metric and the baseline for it. And then in the next step, you just say where you want to receive them, choosing one of the alerting channels that you support. And then when alert triggers, how do I know now what's the root cause of that? So in case of incidents, we start to correlate all the problems that we detect out of the box. And we detect quite a lot. So we currently detect around 250 different problems, right, that come out of the box with Instana, right? So, I mean, not the problems, but the detection of problems, of course. We can automatically detect across all this very bright spectrum of technologies that we support. And in addition to that, thanks to all this automatic discovery that we do, we, in real time, we're building essentially a holistic model of the whole system under management, which means we understand the infrastructure, platform side of it, the logical services and applications running, as well as the interconnections between all those pieces, right? And how we can, why we do that? Because we can do something really cool about it. Namely, we can, when we detect problems, in different pieces of this graph, and then the major incident like this happens, right? We can then traverse our dynamic graph. This is basically that model, and figure out what are related problems that could be, which could explain, right, that incident, that major end user impact we see. And here, just an example, right, of a latency increase on one of the service, and all the related things that have happened, ultimately bubbling up to problems, or one event and one problem that we have detected, namely that our MySQL process got an abnormal termination. So that sounds like a root cause for all our problems since morning. So that's for the root cause analysis. And Roman, back to you. Let's make some conclusions here.
Yeah, thank you, Yury. Let's conclude. So, I mean, I mentioned earlier that SRE is more prescriptive than what DevOps tries to say in a way that it is user focused, right? So everything you do is around critical user journeys. Any SLI and SLO and error budget is tied to it, and it is engineering empowering because it gives the site reliability engineers the possibility to to influence the development cadence, but also it gives it data to talk to other parts of the company, like the product managers, the business side, and to have this argument that, for example, there's more work necessary to achieve higher reliability if the goal is higher than we can achieve. And so basically, in the end, it is something that aligns those three parties, right? The engineers on one side on the seesaw, the operators on the other side, and the business people in the center. That kind of there's no need to argue over if someone should be slower developing and deploying features, or if someone should do a better job monitoring, or someone has unrealistic goals for what the features should be and when they should appear. You have this error budget, everybody can see it, and then it becomes kind of obvious for the developers, for the operators, and for the product managers on what can be done and what should be done going forward. Then, so basically, maybe a couple of kickstart tips is ask yourselves how are requirements agreed between those three parties at your company, as well as so what projects or products are candidates for SRE practices in your company, and how do you respond in times of outages? What kind of culture do you have doing this? Then pick a project, define a user journey, an SLI, SLO. Then you will see if the target that you define for your SLO is realistic, if you have historical data for your performance. And, write those things down. Document those four terminology parts that we had. And but most importantly, iterate, because SRE is not something that is defined once and then set for the lifetime of the product. It's something where you learn while you develop this product, and where you can improve, especially in the way how you handle incidents, and how you do automation to be good at not burning our budget. Okay, I think we are coming to our last slide, and which basically says thank you very much. We would appreciate your feedback a lot, and this bit.ly link goes to a Google form, which is also you can also see in the chat. And I think now we can take some Q&A.
Also, thank you very much from my side.
Yep, absolutely. So we do have just a couple minutes for questions. Please, audience members, rest assured the presenters today are going to get a copy of all of your questions. So if we don't get to it right now, they will be coming back and answering these. Just stay tuned. So with that said, let's just take a couple here. Russell wants to know whether you recommend setting SLIs and SLOs at the UI as well as at the API layer.
Yeah, thanks a lot, Russell. It's a very good question, and I can give you an example. So, for instance, at Google, we set SLIs, SLOs, error budgets, not just for the the front ends that serve the users to model a user experience, but also our other systems that talk to other systems do have SLOs, simply because the user experience depends on them. On some backend systems, if they are down, my user experience will be worse as well. What is important when you define it for an API is that it's something that is relevant to the user experience. Yeah, I think that would be it for this question. Maybe take the next one.
Sure. So James wants to know, can he set below 99 in the tool, such as 98%? I'm assuming that means reliability percent.
Mm-hmm. Yeah, happy to take this question. So yes, of course. So you can set an arbitrary number there. I mean, going to the lower service level objective values. I mean, of course, you can go as low as you want. Going, higher, right? So basically, how many nines you can have. That depends at the end. Ultimately, will have a limit, right? So in case of the time-based APIs, the remaining error budget, right? After choosing how many, that's like a function of the compliance period you have, and in the time-based SLI, that's a function of the compliance period, because in the months there are that many minutes, right? And if you take, let's say, 2 nines, that's 40 minutes, like 3 nines, that's 4 minutes, and then okay, you have no error budget. So error budget unit is minutes. So you can go that high. In case of events, that of course depends on how many events or requests you have in the compliance period, such that you have at least one at the end defining your error budget, because error budget of 0 is not gonna help. I hope that I was able to answer the question.
Thank you so much. I think we probably have time for one more. Let's see. I wanted to, it came up a few times actually in Q&A, the definition of CUJ. And I know, Roman, you said you refer to it as a critical user journey, but how does that differ from a customer user journey? Are those two things separate, or are they just two different ways to refer to the same thing?
I would say it's, in this case, it is the same thing. We want to model the user interaction when they try to achieve a goal. And so this can be a user, which can be a customer that uses the UI, but the user can also be another system that uses my system, my API. Actually, there you could also say it's the critical, some people say critical path through your application stack. But in the end, it's something that your user, whoever it may be, either a customer or a system, should have a successful experience. So should be able to achieve the goal that it wants to do. I don't know, maybe get out of a JSON object from your API, or it could be shopping in your RoboShop, like Yury showed before.
Okay, thank you. So we are just about at 3 minutes to the top of the hour, and I have a couple of things I need to go over, and then we will choose our Amazon gift card winners. So before we do that, though, I need to remind you that today's webinar has been recorded. So if you missed any of it, or you just want to watch the whole thing again, you can definitely do that. We'll be sending an email out to all of you with a link to access that on demand. It will also be available on devops.com/webinars. So look in the on-demand section and it should be there. So now, the part you've all been waiting for, our 4 Amazon gift card winners. Let's see who we have. Our first winner is Joe G. Congratulations, Joe. Check your inbox. We'll be sending out an email for how you can claim that gift card. Our second winner is Rick F. Congratulations, Rick. Next, we have Fabio S. Congratulations. And Richard S. Congratulations to all of our winners. We will, again, be reaching out to you by email. So please check your inbox. If you don't see it, check your spam folder. Thank you so much, Roman and Yury, for this awesome webinar. We really appreciate your time. And thank you very much to the audience for spending an hour with us today. My name is Sharon Florentine. I have been your moderator today. And thanks again. I am signing off.